Following on from the previous video, we got to this stage here where the volume of that complicated solid was given by this. So now it's just a matter of integrating this. Imagine there's the number 1 here. So now integrate it with respect to z. So when you integrate this, it would just be z from here to here, from here to here. So now we need to put this into the z, which will then give us this thing here, and then take away, and then you've got to put this into here. That will then give us this. So now tidy this up. Y squared, 5y squared, so that would be negative 6y squared, and that, well, this whole thing here becomes this. So now now looking at this, integrate it with respect to y. So when you integrate it with respect to y, that will give you 6y. Integrated with respect to y, integrated with respect to y, from here to here, from here to here. So now we can just put this into here. That will then give us this thing here, and then put this into here. That will then give us this. Put this into here. That will then give us this, and then take away, put this into here, put this into here, put this into here. That will then give us this whole thing here. So now it's just a matter of tidying up this complicated thing here. So to tidy up this complicated thing here, you have to let me think. Notice that this thing here is exactly the same as this thing here. So that would become 12 of the exact same thing. And then you've got your, well, this thing here, hang on, this thing here is the same as this thing here. So you've got negative 12 of something, take away another 12 of something, you're going to get negative 24 of the exact same thing. And then this thing here is exactly the same as this thing here, so you're going to have negative 4 of the exact same thing. So if you tidy up this whole thing here, it will then give you this. And then I'm going to visualize this thing here. I'm going to visualize this thing here as a block of exact same thing to the power of 1, and then exact same block to the power of a half. So this would be like this. Hang on. 1 minus 2x squared. So this is to the power of 1 here. That will then give us this, and then this is your square root here. That will then give you this. So this thing here becomes this thing here, and then let me think. What did we do next? Hang on. Oh, this times this times this. That will then give you this thing here. This times this times this. That will then give you this thing here. So now we are currently at this stage here, and then tidy this up. Hang on. Tidy this thing up. Let me think. You've got this thing is exactly the same as this thing here. So 12 lots of something, take away 4 lots, that will give you 8 lots of this exact same thing. And then x squared here, exactly the same, exactly the same. So negative 24 of something, add 8 of something, that will give you 16 of something. Okay, so that would then take you to here. And then notice that this thing is exactly the same as this, so you can factorize out that thing. So that will give you 8, and then 16x squared, and then you can factor out the 8 here. So factor out the 8, that will then give you this thing here, and then you've got 1 minus 2x squared. And then notice that this is exactly the same as this, so you can merge the two together. So that will give you that will then give you exact same thing, but to the power of 3 over 2. So we are now currently here. So it's just a matter of us integrating this thing here from here to here. So integrating this, back to calculus 2 now. We've got to use trigonometric substitution in order to integrate this. So to use trigonometric substitution, looking at this thing here, create a right angle triangle in such a way that this thing will be true. So this is calculus 2. I'm expecting you to know this. If you create the hypotenuse to be 1 and create the opposite to be root 2x, then the adjacent will have no choice but to be square root 1 minus 2x squared. So basically make this substitution here. If you look at sine theta is this thing here. Sine theta equals root 2 over x. So that means find the differential of both sides. So differentiate both sides. So that will then give us this. So hang on, let me think. And then this thing here. Hang on, let me think. If you hang on, let me think. So we need our dx here. So we need our dx. So dx is really divided by root 2 here. So now we can put this into the dx. So that will then give us this thing here. And then looking at this, if you cube this, it will then give you this thing here. So if you cube this, then this thing here would be exactly the same as this thing here. So if you cube this, it would be cos cubed. That's why this is cos cubed. Okay, I didn't explain this bit very well, but think about it. Trigonometric substitution, it will then take you to here. Okay, so now tidy this up. Oh, by the way, here we're integrating from x equals this to x equals this, but because we made this substitution, we need to establish our limits of integration. In the theta world, it would be you integrating. Well, hang on, let's put this into here, into the x. So the square root of 2 will cancel out this square root of 2, so that will become negative 1. And then really you're integrating from negative pi over 2. And then if you put this into here, so that, hang on, if you put this into here, so that would be root 2 times 1 over root 2. These two cancel each other out, it would be 1. But what is that in terms of theta? Well, that would be pi over 2. That would be pi over 2. So really, in the x world, we are integrating from here to here. Because we made this substitution, we are actually integrating from theta equals negative pi over 2 to pi over 2. We've done this in calculus 2, so I'm expecting you to be able to jump from here to here. Okay, so use whichever method you want. I've explained it badly here, but we are integrating from here to here. And you should be able to do it by now. That's calculus 2. So now we are currently here. So now tidy this up. So this is a constant, so take it out. That will then give us this thing here, and then this would be cos to the power of 4. So there are lots of ways of integrating cos to the power of 4. For me, I'm going to use the reduction formula from calculus 2. So if you want to integrate cos to the power of anything, it would be, in our case, n is 4, so this will be a quarter, and then n is 4, so 4 take away 1 would be 3, and then 4 take away 1 will be 3, 4, and then 4 take away 2 will be 2. So and we've done this in calculus 2, so I'm expecting you to be able to jump to here using the reduction formula. So that will then take us to here, and we're integrating from negative pi over 2 to pi over 2. So hang on. So when you put this into here and put this into here, that would be, well, what is, So sine is this, cos is this. So pi, this is pi here. So pi over 2 is 0. So this thing here, cos here would be 0. Well, if you put this into here, put this into here, one of the two must be 0. It turns out to be this to be 0. So that would be 0, and then you take away, well, when you put this into here, put this into here, one of the two would be 0. It's going to be 0 over 0 if you think about it. So this whole thing here will actually be 0. That would then just leave us with this. Okay, so think about it. This thing here will be 0. Okay, because you've got this thing here. One of the two, you've got cos and sine. One of the two will be 0. One of the two will be 0. So you times by 0, the whole thing disappears. Well, anyway, this whole thing here will be 0, leaving us with just this. So now it's just a matter of us integrating this. So now, now let me think. Now take this out. That will then give us this. And then apply the reduction formula again on this. You can use whichever method you want, but for me, I'm going to use the reduction formula again on this. So using this reduction formula again, this n is 2, so it would be 1 over 2. So it would be 1 over 2. So that's this thing here, 1 over 2. And then n is 2, remember. So 2 take away 1 will be 1. And then you've got your sine, and then n is 2, so 2 take away 1 would be 1. N is 2, so that's why this is 2. And then n take away 2, so that would be 0. So this thing here will be the number 1. Okay, will be the number 1. So that will then take us to here. That will then take us to here. So so when you put this into here and into here, one of the two blocks here must be 0. So it will be 0. Put this into here, put this into here. One of the two blocks here would be 0. So the whole thing here would be 0. So it just boils down to this. When you integrate the number 1, which is what this thing is, this is the number 1 here. So when you integrate the number 1, it would just be theta, from negative pi over 2 to pi over 2 to pi over 2. So now let me just take this out first. So that will then give us this thing here. And then put pi over 2, take away a negative thing. So that would be a positive pi over 2. And then simplify it. The overall volume is given by this. Okay?